All right, hackers and hackerettes, welcome to the continuation of file upload vulnerabilities PortSwigger labs. So in the last video, we have done lab number 8, and right now we're going to continue with the content or with the context up until we hit our next lab. Then we're going to solve the lab, and then we will keep going like that. So we're exploiting flawed validation of file uploads. In the wild, it's unlikely that you'll find a website that has no protection against file upload attacks like we saw in the previous lab. But just because defenses are in place, that doesn't mean that they are robust. You can sometimes still exploit flaws in these mechanisms to obtain a web shell for remote code execution. Now, RCE, or remote code execution, is one of the most dangerous and the highest vulnerability that you could report to a bug bounty program, because it essentially allows you to just take full control over the server. Something that companies will definitely not like. Flawed file type validation. When submitting HTML forms, the browser typically sends the provided data in a post request with the content type application xwww form URL encoded. This is fine for sending simple text like your name or address. However, it isn't suitable for sending a large amounts of binary data, which you'll need the multi-part form data for, of course. Yeah. We already know that. And then consider a form containing fields for uploading an image, providing description of it, and entering your username. Submitting such a form might result in a request that looks something like this. So post/images, normalwebsite.com, 12345 length, and then the multi-part form data. It's going to have a boundary and then has like some boundary here, content disposition, name image, file name example, binary content of example, and then the boundary right here. And then disposition, description. This is an interesting description of my image, username, wiener, and so on. As you can see, the message body is split into separate parts. Each of the form's inputs, each part contains a content disposition header, which provides some basic information about the input field it relates to. These individual parts may also contain their own content type header, which tells the server the MIME type of the data it was submitted using this input. Okay, that's cool. Then one way the website's been attempt to validate file uploads is to check that this input specific content type header matches an expected MIME type. If the server is only expecting image files, for example, it may only allow types like image JPEG and image PNG. Problems can arise when the value of this header is implicitly trusted by the server. If no further validation is performed to check whether the contents of the file actually match the supposed MIME type, this defense can easily be bypassed using tools like Burp Repeater. Because this is literally just text in the header, we could essentially just send the file and type that it is an image JPEG, but it's just a PHP file. And web shell upload via content type restriction bypass. It is also a lab that I solved before. Looks like it was part of another series or like another learning path, because I did not finish the file upload vulnerabilities path. So we're going to go through the lab together. Now, the lab contains a vulnerable image upload function. It attempts to prevent users from uploading unexpected file types, but relies on checking the user controllable inputs to do that. Okay, so let's start PortSwigger or Burp Suite. And then we will essentially just go through hacking it together. Let's click access the lab. In order to get access to the lab, open proxy. Let's wait for the lab to load, and then we are going to log into our account. So winner Peter, and then we do have our avatar upload right here, which looks like we could try to upload our... Oh, we don't have data here because I did not enable my Foxy Proxy Burp Suite proxy. I'm gonna filter the traffic to only show traffic that has an address similar to this. And then I'm gonna try to upload my shell, which we created in the previous video. So if you did not watch that, you can watch it. But essentially, it is the most basic form of a PHP shell. So only image JPEG and image PNG are allowed. Sorry, there was an error uploading your file. Okay. So we did not get to upload this file, but let's take a look at the request here. So I can click on the request here, which is the upload request, and then press Control R to send it to the repeater. And then let's see. So we do have our stuff here, and then it's an application octet-stream. Honestly, I'm just gonna do the content type to be image JPEG. I think it is like the most simple thing, and then it has just been uploaded successfully. It even told you in the error message, which is, by the way, another like weakness, that in the error message itself, it just exposed to us what is allowed to be uploaded. So that means it is information disclosure. Essentially, it just helped me as an attacker right now to know what kind of header I could pass in here in order to get my arbitrary PHP web shell to get uploaded to the server. So we could just go to files, avatars, and then PHP shell.php. And then the CMD is going to be cat home Carlos secret. And there we go. We have the value just like that. It is super simple. Let's paste it in here. And again, it says the answer is incorrect. I don't know why it does that. Also, the last time or on the previous video, it did the exact same thing. But I believe it is a bug in the lab because potentially there is like multiple secret files. And we can confirm that by doing just ls and then home Carlos. And then we see we have two secret files, which does not make sense to me. I assume that it is related to me solving the lab previously. So maybe the cleanup of the lab is not done correctly, or maybe because I already have it as solved. It's like, I don't know, duplicating the file somehow, which I don't think even Linux allows that. But let's try to run uname tag A. And we are running on Linux, which means that like this does not make sense to me, honestly. How we can have like two secrets here is beyond me. What we could do is essentially just cat that and then home Carlos secret. Let's see if we can. Okay, so we got both. But are they the same? So both of them include the same value. Which is now even more confusing to me. I thought the problem is that they had different values. But when we like echoed out both of them, it just... Oh, wait a second. Okay, I saw what the problem is. So essentially, when we did cat secret, that means that it was just copying or adding secret to secret, because there are two files that are named secret. So it was echoing it twice, actually. I just noticed that because of this PR7, which is the same ending here. So that means stopping here is one value, and then you can see that it's repeating again. So yeah, this is how you can solve the lab. You probably will not face this issue when you solve the lab yourself. That's because I'm guessing, at least I do not have solid proof. This is related to me solving the lab before. Anyway, so we were able to bypass the very simple protection on the file upload that was implemented by a rookie developer, and we have taken control over the server right now. So Thank you for watching. I will see you in the next set of data and set of context for file upload vulnerabilities, and then we'll solve the lab together. See you.